So again, okay, we are going to start with reaction of an acid with a base is called an acid-base reaction and a proton transfer reaction. So what is going to happen? Acid is something that loses a proton and base is something that gains a proton. So here HCl is an acid because it is losing a proton and H2O is a base because it is gaining a proton. When HCl loses a proton, we take H plus out, what we are left with is Cl minus. When H2O gains a proton, H2O plus H plus will become H3O plus, right? On the reverse side also what we can do is we can see that Cl minus is a base and H3O plus is an acid. So what is happening here? Again, Cl minus is going to gain the proton. Okay, Cl minus is going to gain the proton, and when Cl minus gains the proton, it becomes HCl. When H3O plus act as an acid, it loses a proton, it becomes H2. So from the reverse reaction side also we can see this, right? So Bronsted-Lowry definition is anything which has H can act as potentially as act can act as an acid, and any species that has lone pair it can act as a base because it is going to take the proton, right? So both an acid and base must be present in an acid base reaction, obviously, right? Because an acid cannot lose a proton unless there is a base to accept it, right? Similarly, I cannot sell something if there is no buyers. It's the same thing with acid and base reaction. If there is no one to accept it, I cannot lose it. Most acid-base reactions are reversible. Reversible means we'll use two-headed arrows like we have used here. This is a reversible reaction means A and B form C and D and C and D form A and B. So that can also happen. Irreversible reaction, we use a single arrow here, right? So in irreversible reaction, only A plus B can go to C and D, C plus D. And reversible reaction, both can they can come back also. Now, this is important. Pay attention. When an acid loses a proton, okay, the resulting species without the proton is called its conjugate base of the acid. Okay, okay, what it is called? Conjugate base. So when HCl is losing the proton, Cl minus is called its conjugate base. Got it? An acid has a conjugate base. A base has a conjugate acid. Okay, got it? Yes.
Yes.
Yes, sir.
Okay, you have to say yes sir when I'm asking. Okay, because I'm asking. Anyway, so when a base gains a proton, when a base gains a proton, the resulting species with the proton is called the conjugate acid. So an acid has conjugate base, a base has conjugate acid, right? So HCl is the conjugate acid of Cl minus. So whenever somebody asks me what is the conjugate base, I take H plus out. When somebody asks me what is the conjugate acid, I add H plus, right? Yes, because if somebody asks me what is the conjugate base for HCl, I will take H plus out and Cl minus is remaining. So Cl minus is the conjugate base of HCl. If somebody asks me what is the conjugate acid, this is a base. So for base, we will have a conjugate acid. So how we will I will find its conjugate acid? I will add H plus to this. So H3O plus is its conjugate acid. So to find conjugate acid, H plus must be added. And obviously this is true, right? Because for we are talking about conjugate acid. So if we have to make something acid, we will add H plus to it. And when we are making its conjugate base, we are taking H plus from it, right? So this is so in this reaction, you can see we have acid and its conjugate base, and from this side also we have a base and a conjugate acid, right? Okay, right. So yeah, so acid and their conjugate bases they exist in pair. Another example we can see here. What is happening here? NH3 is a base and H2O is an acid. H2O is an acid. It is oh sorry, H2O is acting as an acid. So when H2O act as an acid, what will be its conjugate base? It will lose H plus, it will become HO minus. NH3 is a base, it takes a proton from NH4 plus. Okay. Now you can see that so far, whatever reactions we were discussing, okay, here H2O was acting as a base. Only in the last reaction it has acted as an acid. Okay, because now water can behave as a base because it has a lone pair, and it can behave as an acid because it has H to donate also. Clear? A strong base is something that has high affinity for proton. A weak base has something which has low affinity for a proton. Got it? Strong base has a high affinity for a proton. I'm a strong base. I need H plus. Weak base is okay. I will. Now this is the most important thing which you have to remember. Stronger the acid, the weaker is its conjugate base. Got it? Stronger
Yes,
the
sir.
acid, weaker is its conjugate base. So if, for example, if HBr is a stronger acid than HCl, so Br minus is a weaker base than Cl minus. Got it? Yes?
Yes, sir.
Yes, sir.
Both of you clear?
Yes.
Okay, excellent. So you have a problem set. One, two, three, four. Chalo, shabash. Start with the problems. Joanna is a program. Joanna is MU and program. Anyways. Which one you are doing, Sanchita?
The fourth one.
Okay.
So I sent the answers.
Okay, very nice. Very nice. Very good. Very good. So what did you do in Diwali, Ananya?
So I went to Sri Lanka.
Okay. So how was it?
It was really good.
Okay. You enjoyed, huh?
Yes, sir.
Sri Lanka is good. Better than India,
So it's much cleaner. Like,
huh? That is better,
yeah.
huh? Right? That is always better. And imagine, huh? The roads are better, huh?
Yes, sir. The roads are much better.
Right? Not like the Bengaluru, huh?
No, it's much better.
Okay. See, I've sent you the answers.
What I've sent.
Okay, I've sent the answers. Please check in the group I've sent. See, in the group I've sent for chapter 2, all the answers. Got it?
Yes, sir.
Yes, sir.
Okay. So you can check your answers till 4 and let me know when you have checked. We'll move.
So I checked.
Okay. So you have heard about log,
Yes, sir.
okay? You know what is a log, huh? For our purposes, we'll just use the calculators, but yeah, still. So you also checked it, Sanchita?
Yes, sir.
See, now we are going to define these quantities pKa and pH. Okay. So when a strong acid such as hydrogen chloride is dissolved in water, almost all the molecules dissociate, that is, they break into ions, which means that the products are favored at equilibrium for the first equation. So since products are favored, you can see the arrow is larger on the forward direction and very small on the back direction. Got it? So we say that the equilibrium lies to the right. When we are using two arrows, it means there is an equilibrium. So equilibrium is towards the right hand side. When we have a much weaker acid such as acetic acid and we dissolve this in water, very few molecules dissociate because it is a weak acid. It will very few will give H plus. So it is a miser acid. It is not giving money, yeah. Okay, that is what it is doing, right? So it is a very miser acid, and this is a very, what do you call, philanthropic acid. It is giving its H plus. So yeah. So for the weak acid, very few will go in the forward direction. So we can see the back arrow is larger, forward arrow is smaller. Okay. So that is how we. So the reactants are favored at equilibrium. Okay. In the case of weak acid, reactants are favored. That is, the equilibrium lies to the left. Okay. A longer arrow is drawn towards the species favored at equilibrium. Okay. So this is the situation here. Now we define something which is we call equilibrium constant of the reaction, K equilibrium. Okay. We use brackets to indicate the concentrations of the reactants and products, okay, in moles per liter. Okay. So consider this reaction. Okay. Ha plus H2O goes to H3O plus A minus. See how we are writing K equilibrium means equilibrium constant. How we write the equilibrium constant for this? First, in the numerator, we write the concentrations of H3O plus and A minus and multiply them, divided by the concentration of Ha and H2O. This is the equilibrium constant for this reaction. Now defining Ka. Now the concentration of water is a pure liquid, it is constant, okay? Excuse me. So we define a new equilibrium constant. We define a new equilibrium constant Ka, which is nothing but K equilibrium multiplied by H2O. Here, we multiply K equilibrium by H2O. We get a new equilibrium constant. We call that K, and it is simply H3O plus A minus Ha. So we can also say that while I have to write the Ka, excuse me, we have to write the Ka or acid dissociation constant. We will simply ignore the concentration of water. We'll assume it to be 1 because pure it is a pure liquid, and we can just write it like this. Clear?
Yes, sir.
Yes, sir.
So this is how it is. Now defining Ka. So I just told you how to define Ka. Now pK is defined as negative log of Ka. So for example, K is given as 1.74 into 10 to the power minus 5. We will simply take negative log of K for this. Negative log of 1.74 into 10 to the power minus 5, and it turns out to be 4.76. Okay. So to reiterate, greater the value of Ka. If K is large, it means what? It means these are large. It means it has gone towards forward direction a lot. So large acid dissociation constant, Ka, right? It means dissociation constant, large dissociation constant Ka means that the acid is very strong. Okay. It means that the acid is very strong. Okay. That is the main thing. If Ka is large, log Ka is large, but negative log K is small. So for very strong acids, Ka is large, log K is large, but negative log K because we have multiplied by minus. So pK is small. So in general, stronger the acid, smaller its pK value. Clear, both of you?
Yes, sir.
Yes, sir.
Okay. So the stronger the acid, the smaller its pK value. Now we define something as pH. pH is getting related to the concentration of, as we can see, pH is getting related to the concentration of hydrogen ion concentration. So pK was negative log K. So pH is nothing but negative log of hydrogen ion concentrations, right? pH is negative log of hydrogen ion concentration, right? pH is equal to negative log of hydrogen ion concentration. See? So, pH values, as the pH values get smaller, it means stronger the acid. Okay? pH values are smaller means stronger the acid. Okay? That is the idea. The more acidic the solution. So, pH values decrease as the acidity of the solution increases. We see that lemon juice is more acidic than coffee and that rain is more acidic than milk. We'll just see the values. So solution with pH values are slightly less than 7 are acidic, whereas those with pH values greater than 7 are basic. The pH of a solution can be simply changed by adding acid or base to the solution. Do not confuse pH and pK. The pH scale is used to describe the acidity of a solution, whereas pK indicates the tendency of a compound to lose its proton. So pKa is characteristic of a particular compound, much like melting or boiling point. Okay, pH will tell you whether the solution is acidic or basic. pH less than 7 is acidic. Okay, human blood is slightly basic, 7.4. Okay. So red zone is acidic. You can see HCl is acidic, gastric juice, lemon juice, cola, vinegar, tomatoes, wine, coffee. Huh? So that is why we get, see, milk also gives you acidity, saliva is also acidic. Now, egg white, seawater, human blood, tears, all these are have started becoming basic. Huh? Baking soda, borax, milk of magnesia, household ammonia, household bleach, NaOH, NaOH. Huh? See? Yeah?
Yes, sir.
Sanchita, clear?
Yes, sir.
Okay. So this is defining pH. Now you can open in alternate window also and we can start also. Okay. So you have to do these questions now. Okay. So for some, you have to take the help of this. So you can just take the screenshot for this also, or you can open the notes in the alternate window. This you need, and you will need this table also. So yeah, you can all open it, or yeah. So yeah, we have to do this. 5 till 9. Shabash, chalo. Which one are you doing, Sanchita?
So 7.
Okay. Ananya, which one you are doing?
So I'm also on the seventh one.
Okay.
So I'm not sure how to solve the seventh question.
pk is negative log k.
Yes, sir.
It means negative log k is given to be 4.82. It implies log k is equal to minus 4.82. Okay,
Yes,
got
sir.
it?
Yes, sir.
Now you have got calculator, everyone.
Um,
So where there is log k, if you'll press the shift button, then instead of the log, so you just first type minus 4.82 in your calculator. You can just type 0 minus 4.82, so it will display minus 4.82. Then you press the shift button and press the log button. But first shift plus log. Do it and tell me the answer. Both of you.
so I got 0.683.
No, that is incorrect. What is written in front of the log button? Above the log button in your calculator?
Um, 10 to the power x.
Yes. So it must be 10 to 1. So if you press first print minus 4.82 and then press shift and then press that button, log button, right? You should get something else. You should get like 1.67 into 10 to power minus 5. This should you get. Let me check. What are you getting?
So I'm still
Sanchita?
getting the same.
No, you should have to get something else. Let me check here. It is, yeah. You should get 0.0000151. So essentially you should get 1, 2, 3, 4, and 5, 0. 1.5 into 10 to power minus 5 you should get. Are you typing minus 4.82?
Yes, sir.
Then you are pressing the shift button, huh?
Yes, sir.
No. Okay, then do one thing. Just type 2 and then use the shift and 10 to power x button. You should get 100. If you are not getting, then you are doing it wrong. Just type 2 and then press shift log button. What are you getting now?
Sir, 1 second.
Huh?
1 second, sir. I'm just.
Okay. Sanchita,
Sir,
type 2 and then type shift log. You should get 100. Are you getting 100?
2. No.
What are you getting? 0.301.
Yes, sir.
No, it means you are that shift is not working. You are just
Oh.
taking the log. Okay. If that shift 10 to the power x, you have to come to that. There's a shift button, right?
Yes, sir.
First, press the shift button and then press the log button. Do the same process again for 2. From 2, you have to make it get 100. You have calculators on your phone, right?
So it's on my laptop. I can write on my phone.
From where do you have Sanchita?
So no, I've been using the laptop.
Okay, shall I'll just send you a link and you download that calculator, okay?
Yes.
And from there you can do as I'm sending it in the group. Huh? Okay, I've sent you download and do that.
But I sent the answers, but when I was solving the seventh one, I didn't use the calculator. I just searched up the 10 to the power minus
Yeah,
4.
you did the Google.
Yeah.
That's also good. But you should learn how to use the calculator. Download that calculator and do it, okay?
Yeah.
Because we'll be using more of it, right? Just give me 1 moment. Yeah, got it.
I sent the answers.
Okay, are you getting the? I'm just interested in that calculator thing.
That's what I'm trying to do right now on YouTube.
Sanchita, you have downloaded?
Yeah, I've downloaded it.
Okay, do that exercise what I told you. Type minus 4.82 and then press shift. It is on the top left hand yellow corner button. That yellow button, shift. And then after pressing shift, you just press the lock button because just above log you'll find that 10 to power x written. So it means that after shifting that 10 to power x will come.
Okay.
Let me know when you get it. Quickly, please. We have to move on.
So I'm not able to download it.
You're not able to download.
No.
Why?
It's saying something the Google account isn't associated with the device.
Okay, no problem. You just work it out later on. Okay. Okay. So this is acid rain. See what acid rain is doing to this statue, huh? Of George Washington, huh? Very dangerous. Sanchita, what does say? Huh?
Sorry, sir, what?
What do you say? See how dangerous acid rain is, huh?
Yeah.
So George Washington has become. So this is what happens to calcium carbonate. Okay. Now we are going to come to this point. Organic acids and bases. Oh. Carboxylic acids. Okay. Now carboxylic acids. What are carboxylic acids? Compounds that have a COOH group. Acetic acid. Formic acids are examples of carboxylic acids. Carboxylic acids have pK value ranging about 3 to 5, so they are weak acids. So from appendix 1, we can find the pK values of large acids, but we just need these two, for example. For now, acetic acid, formic acid. Then we have alcohols. Alcohols are the compounds that have an OH group. They are much weaker acids than carboxylic acids, and their pK value is close to 16. This is methyl alcohol, this is ethyl alcohol. pK values are written. Okay. We know that smaller the pK value, stronger the acid. Larger pK value, weaker acid. Finally, we have amines. Amines are compound that result from replacing one or more of the hydrogen bonded to ammonia with a carbon containing substituent. Okay. So from ammonia, if in one hydrogen, if I make attach CH3, then I will get this. Okay. So this is called methylamine. This is ammonia. You can see their pK is 40 and 36. They are very, very, very weak acids. Okay. In fact, they are so weak that they are actually called bases. Okay. They are most common organic bases. Now we are going to look at protonated compounds. So protonated compounds, again, stronger the acid, weaker its conjugate base. We have known this till now. So when we protonate it, see what has happened. The pK values of protonated amines are about 11. Okay. Because now they will be able to give the H plus easily as compared to their neutral part counterpart. They are very weak. CH3, NH2. But after protonation, they have become very strong acid because now they can give H plus very easily, right? Protonated alcohols and protonated carboxylic acids are very strong acids. Their pK value is less than 0. Protonated alcohol minus 2.5 and protonated acetic acid is minus 6.1. Notice that it is the doubly bonded oxygen of the carboxylic acid that is protonated. Okay. You will see why this is so when you read the problem solving strategy. So this is clear, huh? Till now. So this is just a list, okay, which you have to go through. Okay, these are the acid values for this. Clear?
Yes, sir.
Ananya?
Yes, sir.
Now this is very important. A curved arrow points from the electron donor to the electron acceptor. So see, alcohols, carboxylic acids, and amines are acids and bases. So when we are drawing this, this is acting as an acid and HO minus. So we are starting the curved arrow from the lone pair of electrons. So this curved arrow tells us, I'll use a different color. This curved arrow is telling me that these lone pairs are going to hydrogen and they will make a bond with this, because one line means two electrons, right? One line means two electrons, right? So see, they have formed a bond with this. And the second curved arrow, this shows me with this one, which is breaking. Okay. What is this curved arrow telling me? This curved arrow is telling me that this line, because one line is two electrons, so this line is getting broken and these two electrons will be going to this oxygen atom. So on the left hand side, we can see oxygen has only four electrons or two lone pairs, but on the right hand side, it has three lone pairs. Okay. So curved arrow is a way to track electrons. Similarly, you can see in the bottom example, the arrow will always start from the lone pair of electrons and it will end up on the atom or a single line. So you can see what is happening here. The lone pair of oxygen are going to H, means now they will form a bond. They will form a single line. See, new bond. And in this process, since oxygen was neutral and it has given away its electrons, it will acquire a positive charge. Okay, it will acquire a positive charge. So see what is happening when you can also calculate the formal charge here, or you can also just look at it like this. When the electrons are going from like this, and if it has a negative charge, we are always at increasing it by plus one. So it has negative one. So here it will be neutral, because minus one plus one will be zero. Because it is giving, so it will acquire a positive charge. So here it was neutral, so we add plus one. So here it is plus one. Okay. And the one which is accepting, here we will decrease it by minus 1. If we are giving it plus 1, then it will have minus 1. So it was 0 here, so it become 0 minus 1. Similarly, when it is coming to this, okay, what will happen? Minus 1 will get added. So initially it was plus 1 and minus 1 means 0. So it has, you can see here it is 0. Or you can calculate the formal charge by using formal charge equal to valence electron minus lines plus dots also. But this is much easier, okay, to keep track. When we are giving, we'll keep on adding plus 1 to the original, and whatever whoever is receiving, that will get a the final arrow which is getting, okay, that will get a minus 1. Okay, clear? For
Yes,
the
sir.
Sir.
for the middle hydrogen, it got one, but then it lost one, so it remains as such. Sanchita,
Yes, sir.
clear?
Yes.
Yes.
Okay. So we have to practice this a lot. Okay, these curved arrows, they were given by 1947 Nobel Prize winner in chemistry, Sir Robert Robinson, and there's a special tutorial which we'll be also doing on this. So yeah, this is it. Again, we can see the curved arrow. Again, it is starting like that. So oxygen is already minus one after giving, so it will become neutral, and this oxygen has become negatively charged. Similarly, base, from the top oxygen it is coming, and what is happening? Again, it takes H and it has become plus one because it was zero originally. So whenever the curved arrow from wherever it is starting, for example, it is starting from here, so this will get increased in charge, and the final, and this will get decreased in charge. So this will get minus one here, and it went away, so it get plus one. So hydrogen remains as such. But in the final case, what happened? It is only accepting, so it will become minus one. So, and then this first will become, since it is going, it will become plus one. So you can see it is plus and neutral here, because plus one minus one is zero. Or you can calculate the formal charge on each atom if you want. So how we will calculate the formal charge? Valence electron 6, lines how many? 3, dots 2. So this gives plus 1. You can also calculate. Or formal charge equal to valence electron, lines 2, dots 4 equal to 0. You can do this or do what I just taught you. So this is how it is. Okay. So now you have to gradually remember these values also. But as you practice, you will be able to remember. Similarly, you can see this. An amine can behave as an acid or a base. When it behaves as an acid, it is going to give H plus C. When it behaves as a base, it will be like this. Okay. Okay. Now you have to draw the conjugate acid for this and do problem 11 and problem 12. Okay. शाबाश चलो. Which one you are doing, Sanchita?
The the 10th one.
Ananya?
With ma'am on the temple.
Okay, चलो ठीक है. Send it to me. Huh? I have another class. Okay, bye.
Yes, sir. Thank you, sir. Bye.
Bye. Bye.